Hi, so we have this question right before us, and it's a projectile question, so we have to do justice to this question. All right, so I'm going to read through the question first before I start explaining. So a ball is projected with an initial velocity of 30 meters per second at an angle of projection 30 degrees from the top of a cliff 50 meters. Calculate 1. The height of the ball away from the ground when it is at its maximum height. Then 2. Time taken to reach the ground. Then 3. Calculate the distance of the ball when it hits the ground away from the foot of the cliff. So I've read through the question. I'm going to interpret the question. Now, a ball is projected with an initial velocity of this at an angle. So that takes us angle of projection, that's case 1. So angle of projection goes like this, okay? So what's the angle? 30 degrees. So the ball is going to go in this direction. Okay, good. Then from the top, so this is projected from the top. Okay, from the top. Okay, and the height of the cliff is actually 50 meters. Okay, good. Then we have to calculate the height. So what's the u? The u here is actually 30 meters per second. Okay. Then you have to calculate the height away from the ground when it is at maximum height. This is the maximum height of the ball. So, and this is the ground. Okay, good. Then let's calculate this. Then we also have to calculate the time of flight it takes to reach the ground. Then we also have to calculate the distance of the ball when it hits the ground away from the foot of the cliff. Okay, so that's R. All right, so let's solve this question. So it's kind of complicated, but you just have to take it little by little. Now, as you can see, that this is, I'm going to divide this diagram into two. So I'm going to divide it into, so this is the height, so this is 50 meters. Okay, good. Then this is case 1. All of this here is actually case 1. As you can see, the case 1 diagram. Okay, then we're going to find the height here. Let's call this H2. Let's call this H2. Okay, so can we calculate for the height? Yes, of course we can. Remember that for the case 1, that H is actually equals to U squared sine square theta over 2G. We have our U. That's the only thing we need. We have our theta as well. So let's go to solve. So let's go and solve for H. H becomes U squared. What's my U? My U is 30 meters per 20. Is it 20 or 30? 30 meters per second. So 30 squared multiplied by sine. What's my theta? My theta is 30. That's 30 squared. Okay. Over 2 times G. G is 10 because it was not stated. So we have was 30 squared. So what's 30 squared? 30 squared is 900. 900 multiplied by 1 over 2 squared divided by 20. 0 cancels out 0 here. And so I have my H equals 90 multiplied by 1 over 4 divided by 2. So 90 divided by 4, I'm going to write this as 90 over 4 over 2. And so I'm going to write that as H equals to 90 divided by 4 divided by 2. I think that's it, right? I'm good. Then I can write this as 90 over 4 multiplied by, I'm going to do the reciprocal of that, 1 over 2. Okay, so I have 2 here 1, 2 here, 45. Okay, good. So my h becomes 45 divided by 4. So what's 45 divided by 4? And that's about 11.25 meters. So that's the height. H equals 11.25 meters. So that means this guy here is actually 11.25 meters. All right. So can we calculate for the height away from the ground? Remember that from here to here to here is 50 meters. Then from here to here is 11.25. So what's the height from here to here? So we're going to add up the two heights together, and that's supposed to give us 11.25 plus 50 meters. So 11.25 plus 50 should give us 61.25 meters. So that's the height. Then we have to calculate for the time it takes to actually reach the ground. Now, alright, so we want to calculate for the time to reach the ground. As you can see that we are combining case 1 and case 2 together. So as you can see that this is actually the part at which the ball goes. So, but then this is case 1, right? But I'm going to split this part at which the ball travels. I'm going to split them into 2. So first it's going to go like this. So this is half of the journey of the case 1. Then this is case 2 journey. So I'm using the time of flight, half of the time of flight for the first case, because it's just going half by half. Then the second one is going to be the t. So I'm not going to add the two together to get the total time of the flight. As you can see, this is half of the first one. Then this is the second case, the time of flight of the second case. Okay. So what's the formula for the first case? So the first case has to be 2u sine theta over g. Now, since we're doing just half, I'm going to multiply that by half of this. So 2 is going to cancel out 2, and then t now becomes u sine theta over g. So what's my u? My u is actually 30 meters per second. 30 multiplied by sine, what's my theta? My theta is 30 degrees. That's 30 over my g is 10. So 10 cancels this 3. You are left with 3. And so you have 30 is actually 3 times 10. 30 is actually half. So 3 times half is actually 1.5. So half of that part actually took 1.5 seconds. So that means from here it took 1.5 seconds to get here. Then from this then down this, I'm going to use the second formula for time, and that's getting from h equals to, I just have two formulas for that. H equals to half gt squared. Now we know our h. What's our h for the second case? The height here is actually 61.25. Okay, so we have 61.25 equals half multiplied by 10, then multiplied by t squared. You don't know what that is. And so I can multiply, this is 2 here, 1, 2 here, 5, And so I have 61.25 equals to 5t squared. I can divide both sides by 5. And so 5 cancels out 5. I'm left with t squared equals 61.25 multiplied by, so divided by 5, that's 12.25. So square root both sides. So my t now becomes square root of 12.25. That's 3.5 seconds. Alright, so since the time here gives us 1.5 seconds and this gives us 3.5 seconds, so what is the total time I took the ball to travel back to the ground? That's 3.5. So the time of flight is actually t equals 3.5 plus 1.5, and that gives us about 5 seconds to do that. Then the second question says that we should calculate so the third question says calculate the distance of the ball when it hits the ground away from the foot. So saying calculate from here to here. So what is that going to be? Remember that we also have to take the range from here the same way we did it. The range, half of this is still going to be half of r here and then r here for the second. This one is case 1, half for case 1 and the r for case 2. So what's the formula for r of case 1? So r becomes, r for case 1 is actually u squared sine 2 theta over g. What's our u? Our u is actually 30 squared. Remember that doing half of that, so let me just multiply that by half. So that becomes u squared sine 2 theta over 2g. So my r for the first part is actually 30 squared multiplied by sine 2 times 30, 30 is the theta, divided by 2 times 10, and that gives us 900 multiplied by sine 60 divided by 20. So 0 cancels out 0, and so I am left with 90 multiplied by sine 60 is actually 0.8660, then divided by 2, and that gives us 90 times 0.8660. That's going to give us 77.94 divided by 2, and that gives us about 38.97, and approximately the out there becomes 39 meters. So what that means is that here, this place here is actually 39 meters. From here to here is 39 meters. So how do you calculate from here to here? How do you calculate from there to there? Now you're using the second formula for the range, the second case, and that's r equals to ux multiplied by t. So that's going to be weird because we don't even have our ux, but we know our t. Our t is 35 seconds. That's what we got here. But what do we get for our ux? Now our ux is actually u cos theta. That is our ux. So we're going to write that as this as r equals ux times t, and that becomes ux is u cos theta multiplied by t. So what's our u? Our u is 30 times cos 30 multiplied by, what's our t? Our t there is 3.5. We checked that earlier. 3.5. So r becomes 30 multiplied by, so cos 30 is actually 0.8660 multiplied by 3.5 multiplied by 3.5, and so our r becomes 90 point, so r becomes 90.93 meters. So that's our r for that. And so you have 90.93 here. So what's the total distance? That's 39 plus 90.13. So you have your total is total r is 39 plus 90.93, and that gives us 129.93 meters. So that is the answer to that question. So this is how to solve case 3 questions. So case 2 is kind of complex, but you just have to look at it critically before you start solving. All right, so bye.